Here's our introduction on how to think about the second law of thermodynamics. Now, the first law of thermodynamics was a simple equation. It was simply the change in internal energy of a gas equals the heat added to the gas minus the work done by the gas. Very straightforward. So any thermodynamic process, you knew that always to be true. But the second law of thermodynamics is not expressed in terms of an equation. It's expressed in terms of a concept. It's expressed in terms of what cannot happen in thermodynamics. So anytime we try to explain the second law of thermodynamics, it should start with the words such as "it is impossible." And it turns out that there's different ways in which to look at the second law of thermodynamics. Again, to look at what is not possible. So the first way we're going to look at is in terms of the efficiency of an engine. Like we said before, an engine works by extracting heat from a reservoir, taking part of that and making an engine work so we can do work with the engine, and then expelling some of the heat that was obtained from the hot reservoir into a cold reservoir, or just simply expelling it, exhausting it. And as we expressed before, that the efficiency of an engine is simply a ratio of how much work we can do relative to the amount of heat that we extract. So again, we can write that the efficiency is simply equal to work divided by Q hot. And of course, for that to be 100%, we want then all of the heat to be used to do work. Example, what we have here to the right. And it turns out in thermodynamics that is simply not possible. They say that it's not possible to extract all of the heat and use all of it to do work. So a way to look at that would be to have the different form of this equation. For example, we could say that the work done by the engine is equal to Q hot minus Q cold, and if we replace the work in our equation there by that, we get the following. We get the efficiency is equal to the difference, Q hot minus Q cold divided by Q hot. And then the only way in which we can then get 100% efficiency is if this portion of that equation goes to zero. If this goes to zero, then we have efficiency is Q hot divided by Q hot, and that would be 100%. So what that really means then is that in any gases used in an engine, when the gas is expelled from the engine, there would be no energy left in that gas. In other words, the temperature would have to be absolute zero. And that's another way of saying that that can't happen. The second law of thermodynamics doesn't allow absolute temperature of the temperature of absolute zero to be reached. So for this to be true, you need T cold of the exhaust being exhausted to be equal to 0 Kelvin, and we know that's not possible as well. So the best way to express then the second law of thermodynamics in the case of looking at it in terms of efficiency is to say that it is impossible to extract Q hot and use all of it to perform work. And that, simply stated, is one way to express the second law of thermodynamics. There are several others, and we'll explore those as well, but this is the main one, and you can see that on the next ones, they kind of are derived from this. But simply said, if someone says, I discovered an engine, and I can use it to get 100% of its energy and use it all for work, you can be absolutely certain that that engine is not real. All right, second law of thermodynamics in a simple manner.